Hello, this is Kautar Badran, and this is my bridge design pattern presentation. To begin with the intent, this pattern decouples an abstraction from its implementation so that these two can vary independently. And it does that by adding a bridge structure between the abstraction and implementation classes. So each one of these can be extended or modified separately. To put it in simpler terms, this pattern uses an interface that allows us to split a large class or set of related classes into two or more hierarchies, which are the abstraction and the implementation. Now, to make sure we understand this pattern, when we refer to abstraction and implementation in its definition, we mean by abstraction the user interface, for example, or any high-level control layer that receives user requests and sends these requests to the layer underneath it, which performs the low-level operations. And we can refer to this lower level or the implementation as, for example, the system code API. So we can see how the bridge pattern helps us develop the interface and the underlying code separately. Let's take, for example, a shape object, and we want this shape object to have a color. If we wanted to go about developing an application, we may probably use inheritance. Now, the problem with inheritance is that it's going to be forever binding the shape with the color or the implementation underneath it. So we'll end up with a model that looks like this. However, this model comes with its own set of problems. We can see that every time you wanted to add a new shape or color type, it's going to grow exponentially. In addition, it lacks flexibility, as we can see in the previous slide, because this tight coupling between the shape and the object makes it difficult for us to change the implementation or the color of a shape at runtime. And finally, translating the line code would be difficult because we would have to recreate the entire object if we wanted to change its implementation or color. So the bridge pattern solves these problems by preferring composition instead of inheritance when it comes to linking the abstraction with the implementer. And what this means is that the shape is going to have an implementation object inside of it that is linked to a concrete implementer, which in this case is the color. In this way, we would have this simpler model that allows these two hierarchies to grow independently. So let's discuss the structure of this pattern. We have the abstraction, which as we've mentioned before represents the user interface. The implementation has these abstract methods that perform the underlying functions. Concrete implementations further define these abstract methods so that they are specific to each platform of the implementation. And the refined abstraction is simply a type of the abstraction that the user is going to interact with, and it's going to be linked to the concrete implementations, and it may have additional features. So as we can see, this is the bridge structure, and it allows every refined abstraction object to be linked to a concrete implementation using this bridge structure. So this is the implementation object inside of it. And this also allows every refined abstraction to have more than one concrete implementation. As a result, we have additional flexibility because now the user interface or the client using that interface does not have to worry about the implementation being used, and we can also change the implementer being used by that interface at runtime by simply reassigning the value of the implementer object inside that interface. In addition, we have more flexibility while developing the code because now we can develop or extend the interface separately from the underlying implementer without having to worry about them interfering with each other. And finally, the bridge allows the hiding of the implementer of an abstraction due to this decoupling that it performs. And this could be useful in a lot of cases. So the bridge pattern can have several known uses. It is particularly resourceful in applications that have proliferations of classes. For example, C++ uses a library called AT++, which is a fundamental component for having a Windows system. With the bridge pattern, it has an abstraction and its implementers, and it creates platform-specific fonts, cursors, and it responds to window resizes. Another library called libg++ also uses the bridge pattern so that we are able to use very common data structures such as the linked list and the hash table. A well-known graphical user interface toolkit, also called NextAppKit, helps developers handle image abstractions by using the bridge pattern. So it makes developers' jobs easier when it comes to handling these images by selecting the most suitable implementer of an image abstraction in case it could have multiple options, and it can even convert an implementation to another. To demonstrate the use of a bridge pattern, we have an example application. The main idea behind it is a panel that enables the user to select a PC accessory device and connect it to the PC in different ways. So this is the same structure we've seen a couple of slides ago, it just applies to our program in particular. The I connection here is the implementer. It declares functions regarding how the connection is going to work. And the concrete implementers here are going to implement these functions based on specifically how that type of connection works. The accessory device is going to have member variables regarding that device, and whenever it wants to perform any functions regarding connecting to the PC, it's going to be using the functions implemented by the concrete implementer, whose object is going to be contained inside the accessory device object. And these are the refined abstractions that are going to implement these functions specifically relevant to how that refined abstraction works. So the organization of the files in this project shows that the accessory device is our abstraction. It's the general representation of the device. The refined abstractions represent the specific devices, the types of devices that the user is going to be interacting with and requesting to connect them to the PC. The implementer represents the general connection interface, and the concrete implementers are going to be the different connection types. So let's look at the code. This is the implementer, iConnection, and it has several abstract methods regarding starting, stopping a connection, for example. Notice that none of them are implemented here, and they all take a parameter of the device string, which is going to be passed by the refined abstraction that's going to be using this method. This is a type of concrete implementer, and it's the Bluetooth, for example. This implements the functions we saw earlier in the implementer, specifically related to Bluetooth. So for example, starting a connection displays a message that we're turning on Bluetooth and now it's connected. Stopping a connection checks first if it is connected and then displays a message saying your Bluetooth device is not connected anymore. Of course, this is just a simple application. In real applications, the concrete implementer would actually establish that Bluetooth connection, which is beyond of the scope of this project. So to continue looking at the concrete implementer, the Bluetooth displays also Bluetooth related messages when refreshing or showing the connection status. We have other concrete implementers such as the wired and USB dongle, which represent different types of connections. They similarly just implement the functions of the interface in ways that are related to specifically that concrete implementer. So for example, the wired concrete implementer displays messages regarding plugging and unplugging the wire or cable of the device. And it has some members that are specifically related to wired devices, for example, such as the port module. The USB dongle does the same. It just implements the implementer functions, stopping a connection, refreshing it, starting it, by displaying these messages that are related specifically to the USB dongle. And it has some members, just as the others that are related specifically to this type of connection, such as the port number, or whether the USB dongle is plugged or not. Now let's look at the abstraction code. This is the accessory device, the general device representation, and it's going to have members regarding the name and brand. Most importantly, this is the object representing the concrete implementer. However, it does not specify which implementer over here. It is only specified when it is created at runtime. It's being passed to the constructor along with the name and brand, and then it gets assigned. This shows how easy it is to just change the type of concrete implementer at runtime by just reassigning the value of this object. And it has abstract methods regarding connecting and disconnecting and refreshing. These are implemented in refined abstractions. So this is one of our refined abstractions, the headset. As we can see, it has its constructor which calls the base or the general accessory device constructor. It gets and passes the parameters required, including the type of concrete implementer. So as we can see, whenever it wants to connect or disconnect, perform any function regarding the connection, it is going to be using the concrete implementer object, which is going to call its specific functions regarding these connections. And it's going to pass the brand and name of the device, which are related to the headset, which are inherited from the accessory device. And this way, the messages displayed are going to be relevant to the concrete implementer and this type of accessory device at the same time. And as we can see, we have some functions that are related specifically to the headset. These aren't inherited, so it's just related to the headset, and they just display messages showing that this is the headset being used, and these two functions are called in the connection method. So we have two other refined abstraction objects. These are the keyboard and the mouse. Similarly, they just have the concrete implementer object, and whenever they wanted to perform some connection-specific functions, they just call the methods of the concrete object implementer, which is being set at runtime by passing that implementer to the constructor when creating the mouse object, and which is going to pass to the base constructor of the accessory device, since it inherits from it. And of course, the mouse also and keyboard have some functions related specifically to that refined abstraction. So the mouse has right click and left click, displays messages, and these are going to be used in the starting the connection method. And the keyboard similarly has a key press function that's just going to display a keyboard specific message. So let's look at the main program. First, it's going to display a menu regarding what the user wants in terms of which device. It's going to display the mouse, keyboard, headset menu, and after the user chooses, of course, if the input was valid, the program is going to display the second menu regarding the type of connection. This shows how the bridge pattern is being used because we have objects growing in two different dimensions. There's the device and the connection type. So this connection type is going to be our implementer, and the type of device that the user is going to be interacting with is going to be our abstraction. So after that, depending on the user's choice, the user is going to have to choose whether they wanted to connect or disconnect, refresh, or show the connection status based on this menu over here. And of course, they can select another device or exit the panel to end the program. So let's see this program running. Okay, so first of all, we have this menu for choosing the device. Let's say I want to connect my mouse. It says choose the connection method. Let's say it uses a USB dongle. Okay, first of all, I'd like to connect it. It's saying it's processing the USB dongle, and now it's specifying that my wireless mouse is now connected through the USB dongle, and I can use the right click and left click, of course. And notice how this is all related to both the type of the connection and the type of the device that I'm using. Let's say I want to refresh the device's connection. It's going to tell me unplug and replug, and it should be better now. Let's say I want to see the connection status. Again, it's specifying in every message the type of device and the connection, and that's because my refined abstraction, the mouse, is using the USB dongle concrete implementer. Let's say I want to select another device, and this time I want a headset that uses Bluetooth. And I would like to, let's see, the connection status. It's going to tell me it's not connected yet through Bluetooth. So that's specifically what I chose. And let's say I want to connect it. Now it's telling me it's turning on Bluetooth and that it's connected through it. I can start speaking and listening with it. Let's say I want to refresh the device's connection, and it's going to tell me bring it closer. Let's say I want to see the connection device status, and it's going to tell me it's strong. Let's say I want to disconnect it. It's telling me I have disconnected that device. So notice how from a user perspective, we have no idea how everything is implemented on the inside. We just see how the connection method is being used along with the device that we chose. And notice how we have three types of devices and three types of connections. And in every time we perform an action, it's going to be specifically for that device and that type of connection. Let's take a closer look at how that concrete implementer is being assigned in the constructor of the refined abstraction. This is the area of the code where the device is being set along with its connection method. So this happens only after the user selects a valid device and connection type. So let's look at that function. It gets the device choice and the connection choice in terms of letters that the user enters. So let's start with the implementer. It first declares this object of the type of our implementer, iConnection, and if the user chooses Bluetooth, it creates a new Bluetooth concrete object. The same for the USB, dongle, and wire. These are concrete implementer objects. And then the program sees which device the user chose. The user chose mouse, it creates a refined abstraction object for mouse, and it passes the selected connection, which was set on top here. So if the user chose Bluetooth, the selected connection is now set to an object of the concrete implementer Bluetooth. And the same if the user chose USB, dongle, and wired. And when we come here, if the user chose keyboard, for example, the keyboard specifically a constructor is being used and the selected connection is being passed. So if we go back and look at the keyboard's constructor, it's being passed over here, and the base, it's being passed again. Let's look at the base, the accessory device constructor. This is the connection method, which takes in the concrete implementer type, and then the connection type is being assigned here. So notice how easy it is at runtime. If the user just decided he wanted to change the type of connection, we would display that option in the menu, and then all we'd have to do is just use this constructor with the different type of concrete implementer that the user chose. An important aspect to notice is that if we ever wanted to add a refined abstraction or change the accessory device itself, the abstraction, we wouldn't have to worry about changing the concrete implementers because it's developed separately. And the concrete implementer is only being set at runtime. So at this point in time, the abstraction doesn't have to worry about the concrete implementer. And the same applies to the implementation of the connection. So if we ever wanted to add some functions here, we wouldn't have to worry about changing the refined abstraction. So extending this project becomes easier with the bridge pattern. So just to give credit for the sources I've referenced, and I hope this clarified the concept and use of the bridge design pattern. Thank you.